Hello everyone. In this video, we are going to learn deletion and doubly linked list. There are three different variations in deletion operation, that is delete from the beginning, delete from an end, and delete a specific node. Let us have a look at them one by one with example and C code. Let us now start with our deletion from the beginning. When we say that a first node is required to be deleted, this means header would be required to be shifted to point to a next node, which is a second node in the list. So for that, we are taking a p pointer to p is initialized to point to a first node. Now header is required to be moved to a next node. So header's address is required to be updated with the next part of P, which is the address of a next node in a list. So AB4423 is an address of a second node which is required to be written inside a header. So this statement writes the address over here. Now header points to a second node. Now when I say header is updated, again the second node's previous field is required to be updated, which is still pointing to a node number 20. So for that we will have to shift P to point to a next of P. When P points over here to a new first node, in that case we can easily write previous part of P to null by removing that field and by reallocating a memory of 20. Now this is our list where the first node is deleted from the beginning. This is a code for deletion of from the beginning. As usual, the first thing would we have to check for a list to be empty or not. If header is null, does mean list is empty and we will have to return -1 to a calling function. If not, we will follow the procedure that was shown with an example, initializing P with an header. T is a temporary variable that I took in order to store the data of the node that will be deleted. So that's what we are doing, writing a data part of P inside a temporary variable T, so that later we can return that value from this function to a calling function. Once this is done, we will have to shift the header to point to a next, followed by which we have to shift this P to point to header. Header now contains the new value. So instead of writing P equal to next of P, we can also write P equal to header, because header now points to a second node in the list. We have already shifted the header to a next node. Once we are done with this, we will update a previous part to a null, and once we are done with all that thing, we will return control back along with the value that is deleted. This is how we delete a node from the beginning. Now if we want to delete a node from an end, we have to iterate over a list in order to find the last node. For that iteration, we'll have to initialize P to point to a first node in the list. The address we will get it from the header. So we say that P is initialized with header, followed by which we will have this while loop which will just keep on moving forward unless and until it gets the next value of a current pointer to be equal to null. So here first node it is pointing, it shows a valid address in a next part. So P will jump to point to a next node. Again it shows a next part has a valid address, it's not null. So we'll again move ahead to point to a node 15. Again here it shows BC9979, which is valid address, it's not null. So we'll go ahead. Once it reaches to a node number 30, its next value is found to be null. So P pointer will stop over here and we will be out of while loop. Once we are out of while loop, we have to make P to point to its previous node, because the next part of a previous node is required to be updated with a null. So once we are out of while loop, we will shift this P to point to a previous node by writing P equal to previous of P. If we were not having two pointers, in that case we would have to take two different pointers in order to update this particular address. But as this is a doubly linked list, at any time we can come back to a previous node. So this is how we are utilizing the same pointer in order to update this address. Once we are done with that, we will have to update this next part of p with a null value. Once we update that next part of p to be equal to null, and there is no reference to a node number 30 in this list, and node is considered to be deleted. If you want to free up the memory, you can use a free function in order to release that memory. Here also, as usual, we'll have to check for a list to be empty. So this part remains same irrespective of which deletion you are going for. So header is equal to null, list would be empty, and we will be returning control back with a value -1. If not, this is the same code that we have seen in the example, initializing p to a header, followed by which having a while loop to iterate till the last node. Once we are at the last node, we will shift a pointer p to move back to one step back so as to point to a second last node and updating a next part with a value null. Let us now have a look at a deletion of a specific node. When I say I have to delete a specific node, does mean I'll be coming up with a value to be deleted. Now, when I say I have to delete a node number 15, in that case, I'll have to have a while loop which will iterate till the end of list till p becomes null, so that we can check for the value of the last node as well. If we write next part of p not equal to null, in that case it will not check for the value in the last node. That's why we have to write p not equal to null. This p will be incremented unless and until we get our desired value. Now our desired value is 15, which is required to be deleted. So I'll compare if data part of p, which is 10 right now, equal to 15, condition goes wrong. If this condition goes wrong, we will just increment a p pointer to point to a next node. So p moves ahead to point to a 15. Again, p is not null, it is pointing to a valid address. So we are inside this while loop, again checking for the data part of p with our desired value, which is 15. Now this condition goes true. Does mean we found out the node which is required to be deleted. So now we will take a q pointer which will point to a next node. Now two updations are required to be done. One is over here, where we have to replace the value of this address with a value which is an address of q, and the other is we have to replace this previous one with a value of this AB4423. So these two updations are required to be done in this case. So q is now pointing to a next node after the node that we have to delete. Once we are done with this, we will check for a q to be null. If q is null, it may be possible that this was the last node. In that case, q would be null. In that case, I should not execute this. But in our case, in this example, q is not null, q is pointing to a valid address. So we will replace this previous part of q with a previous part of p. When I get a value from the previous part of p, it would be an address of a node number 10. So this value would be removed and AB4423 is written over here so as to create this particular link. Now once we are done with this, we have to shift p to point to a previous node because we have to update this part, that is the next part of p. By writing p equal to p previous, this p pointer shifts to a previous node. Once we are done shifting it, we will have to update this p next with a value, that is BC9979, which is the value of q. So next of p equal to q. So this node gets deleted. If you want, you can free up the memory, but if you are not freeing up the memory, automatically there is no reference to reach to that node. So at an end of program, the node gets deleted. So once we are done with our task, we will have to break this while loop and we are out of this while. This node is considered to be deleted. This is how a deletion of a specific node works. Let us have a look at the code. This part remains same. Header is null, then that shows an empty list and we are returning control back. This is the same thing that we have seen in the example, initializing p with header, continuing a while loop till null part. checking for the data value, updating a queue to point to a next part of a node that we found to be deleted, followed by which we will have to check for queue to be null. If it's null, we will not execute this. If not, we can go for executing this. I hope this deletion of a specific node is clear to everyone. Let us now have a look at a traversal. When I say it's a traversing a linked list, does mean moving across the list in order to display its value. So we will take a pointer p which is initialized with header, which will start from the first node, and every time it moves to a next node printing its value. So unless and until p becomes null, it will print the data part of p and it will go to a next node in the list. So instead of our link, we will write next over here. P moves ahead, it will print 10. It goes ahead, it will print 15. It moves ahead and it will print 30. So once it reaches null value, because every time we are moving to our next P equal to next part of P. This is how a traversal works. Thank you everyone for watching. Please like and subscribe to my channel.